Early in the 1940s, Ford engineers planned to use the most cutting-edge aircraft engine possible to take the world by storm. But instead of flying, this beast ended up crawling through mud and smoke on European battlefields, powering America's iconic Sherman tank in World War II. Introducing the Ford GAA V8, an 18-liter beast that served as the foundation of Allied armored warfare after starting as aviation royalty. It was originally a 27-liter V12 engine designed to compete with the Rolls-Royce Merlin. It had all-aluminum construction, 4 valves per cylinder, and dual overhead cams, technology that was decades ahead of its time. We're revealing 21 of the most bizarre, outrageous, and unexpected facts about the fabled V8 in this video. Hit that subscribe button right away and hype if you've loved this video so far. 1. Born from aviation dreams, the GAA started as aircraft royalty. Henry Ford had a vision in the late 1930s. He wanted to control the market for aircraft engines because he believed that the skies were going to turn into a battlefield. His group created a groundbreaking 27-liter V12 engine that was well ahead of its time. It's essentially a rocket engine in an engine bay with 4 valves per cylinder, 2 overhead cams, and an aluminum construction that made it both strong and light. Ford was so confident that he went all in. The tooling and casting cores for full-scale production were already ordered before any official military contract was signed. And the prototype didn't disappoint. It reportedly produced a remarkable 1,800 horsepower on its first test run, far surpassing the Rolls-Royce Merlin. But dreams meet reality. The U.S. military preferred tried-and-true air-cooled radial engines over liquid-cooled V12, so Ford's aviation ambitions were grounded before they could really take off. 2. The 18-liter displacement made it America's largest production V8. When Ford's brilliant V12 for aircraft got shot down, the company was staring at millions in wasted development costs. Instead of recycling it, Ford pivoted, cut 4 cylinders, and turned the rejected airplane engine into something the Army desperately needed: a powerhouse for the M4 Sherman tank. The result? The GAA, displacing a massive 1,100 cubic inches, 18 liters, the largest gasoline V8 ever mass-produced in the US and arguably the world. To give you an idea, a modern Dodge Hellcat's V8 clocks in at just 6.2 liters, less than a third of the GAA's size. That kind of scale wasn't just for bragging rights, it delivered monstrous low-end torque. Exactly what you need to shove dozens of tons of armor over rough terrain. Early in the 1940s, Ford engineers planned to use the most cutting-edge aircraft engine possible to take the world by storm. But instead of flying, this beast ended up crawling through mud and smoke on European battlefields, powering America's iconic Sherman tank in World War II. Introducing the Ford GAA V8, an 18-liter beast that served as the foundation of Allied armored warfare after starting as aviation royalty. It was originally a 27-liter V12 engine designed to compete with the Rolls-Royce Merlin. It had all-aluminum construction, 4 valves per cylinder, and dual overhead cams, technology that was decades ahead of its time. We're revealing 21 of the most bizarre, outrageous, and unexpected facts about the fabled V8 in this video. Hit that subscribe button right away and hype if you've loved this video so far. 1. Born from aviation dreams, the GAA started as aircraft royalty. Henry Ford had a vision in the late 1930s. He wanted to control the market for aircraft engines because he believed that the skies were going to turn into a battlefield. His group created a groundbreaking 27-liter V12 engine that was well ahead of its time. It's essentially a rocket engine in an engine bay with 4 valves per cylinder, 2 overhead cams, and an aluminum construction that made it both strong and light. Ford was so confident that he went all in. The tooling and casting cores for full-scale production were already ordered before any official military contract was signed. And the prototype didn't disappoint. It reportedly produced a remarkable 1,800 horsepower on its first test run, far surpassing the Rolls-Royce Merlin. But dreams meet reality. The U.S. military preferred tried-and-true air-cooled radial engines over liquid-cooled V12, so Ford's aviation ambitions were grounded before they could really take off. 2. The 18-liter displacement made it America's largest production V8. When Ford's brilliant V12 for aircraft got shot down, the company was staring at millions in wasted development costs. Instead of recycling it, Ford pivoted, cut 4 cylinders, and turned the rejected airplane engine into something the Army desperately needed: a powerhouse for the M4 Sherman tank. The result? The GAA displacing a massive 1,100 cubic inches, 18 liters, the largest gasoline V8 ever mass-produced in the US and arguably the world. To give you an idea, a modern Dodge Hellcat's V8 clocks in at just 6.2 liters, less than a third of the GAA's size. That kind of scale wasn't just for bragging rights, it delivered monstrous low-end torque. Exactly what you need to shove dozens of tons of armor over rough terrain. 3. Factory output of 500 horsepower barely scratched this engine's potential. On paper, the GAA was rated at 500 horsepower at 2,600 revolutions per minute, reliable, safe, and conservative. But in reality, this V8 had a hidden beast inside. Independent tests showed it could rev all the way to 3,800 RPM before the valves even began to protest, meaning the Sherman's power ceiling was far higher than Ford officially claimed. Tank crews quickly learned a trick in combat. By turning off the governor, which normally capped engine speed, they could release much more power. This made an already strong tank extremely fast, perfect for escaping German attacks or smashing through enemy positions. The tweak became so common that maintenance crews often didn't bother checking it, knowing that letting the GAA run at full power could mean the difference between life and death. 4. Every part used gears for maximum reliability. The GAA engine wasn't just strong, it was super reliable. Unlike most engines that use chains or belts to run valves and other parts, this engine used gears for everything. Camshafts, distributors, oil pumps, and water pumps. Every single part moved thanks to precise gear systems. This wasn't just a neat engineering trick, it could save lives. In battle, a broken belt or stretched chain could stop a tank dead in its tracks, and crews didn't have a garage to fix it. The GAA's front-mounted 8-way gear drive kept every part moving in perfect sync, cutting down failures a lot. Mechanics loved how precise it was, even if it cost a lot. And the results were amazing. Army tests showed these engines could run over 2,000 miles, or 255 engine hours, without losing power. 5. Advanced DOHC design with hemispherical combustion chambers. The GAA wasn't just a normal tank engine, it was way ahead of its time. Ford gave it a true double overhead camshaft, DOHC design, with 4 valves per cylinder and hemispherical, dome-shaped combustion chambers. This kind of tech didn't become common in regular sports cars until the 1980s or 1990s. Each cylinder head was like a tiny masterpiece, built with extreme precision. The intake valves were huge, 2.12 inches, and the exhaust valves were 1.90 inches. The dome-shaped chambers helped the fuel and air burn faster and more efficiently, getting more power from every explosion. The cam system was also special. Instead of using rocker arms like most engines, the GAA's camshafts pushed directly on the valves with bucket-style followers. This meant fewer moving parts, less weight, and more reliability at very high engine speeds. With 0.500 inches of cam lift and 240 degrees of duration, even modern performance engines would respect it. 6. Twin magnetos and dual spark plugs for military-grade reliability. Ford understood that in battle, a single engine failure could be deadly. That's why the GAA engine used a fully redundant ignition system borrowed from aircraft technology. Each cylinder had 2 spark plugs, and each spark plug was powered by its own magneto. So if one magnet failed, the other could keep the engine running. This wasn't just over-engineering, it was a life-saving design for combat. The magnetos were American Bosch MJF 4A units, with one spinning left and the other right, completely independent. This meant that even if shrapnel, dirt, or battlefield damage knocked out one system, the engine could keep running without interruption. There was an extra benefit too. 2 spark plugs per cylinder created 2 flame fronts in the combustion chamber. This made the fuel burn more completely, increasing power and improving fuel efficiency. 7. Flat plane crankshaft design, connected to exotic racing heritage. One of the GAA's oddest features was its flat plane crankshaft, a design more often seen in Ferrari race engines or Formula One cars than in a tank. This wasn't just a bold choice, it came straight from the engine's aircraft roots. Flat plane cranks are lighter and better balanced at high RPMs, which made sense when the engine was first intended to power aircraft. The design also gave the GAA a very specific firing order, producing a unique exhaust tone. You can even trace its influence decades later in Ford's Shelby GT350 Voodoo engine. But there was a trade-off. Flat-plane cranks vibrate more than the traditional cross-plane design, and the GAA needed a massive 198-pound flywheel just to smooth things out. That flywheel was crucial for tank use, helping the engine deliver consistent power even at the low RPMs typical of armored vehicles. It was exotic tech adapted for gritty, real-world combat. 8. Twin Stromberg carburetors fed. This aluminum giant, fueling the GAA was no small task, and Ford solved it with twin Stromberg NAY5G carburetors. These weren't your average carbs, they had giant venturies built to feed this massive engine. Positioned on either side, they created some tricky fuel distribution quirks. Cylinders in the middle tended to run a bit leaner, while the outer cylinders ran richer. Despite these challenges, the carburetors were battle-tested and remarkably reliable. Unlike modern electronic fuel injection, which relies on sensors and computers, these mechanical Strombergs could keep running even after taking damage in combat. Their cross-flow induction system also helped the engine breathe efficiently, optimizing cylinder filling and squeezing out impressive torque across the RPM range. 9. All-aluminum body made it light for planes but strong for tanks. The GAA engine was made completely from aluminum, a big deal in the 1940s. Ford used advanced casting to make the engine block as one single piece, which was very hard to do back then. Most engines, like the Rolls-Royce Merlin, were made from many separate parts. The GAA's one-piece block was lighter and stiffer, giving it an advantage. Using aluminum saved hundreds of pounds compared to heavy iron engines. This was important for planes at first, but it also helped tanks move and handle better, even with such a big engine. Ford had tried one-piece V engine blocks before in their flathead V8s, and the GAA was the best example. Its design included reinforcing ribs and a side oiler system, which Ford later used in their famous 427 racing engines. 10. Hand-welded stainless steel exhausts, tank luxury. Most tank engines of the time used plain cast iron exhaust manifolds, but the GAA went in a completely different direction. It had hand-welded stainless steel exhaust manifolds made from two separate halves. This process was expensive and painstaking, almost luxurious considering it was built for a military vehicle. But the choice wasn't just for show. It offered serious advantages in weight savings and long-term corrosion resistance. The stainless steel design was a clear nod to the engine's aviation roots, where every pound counted and reliability over time was essential. These manifolds had to endure extreme heat and repeated thermal cycling while still holding up under the punishing conditions of combat. 11. Five-ring piston design was overbuilt for extreme longevity. The GAA's pistons weren't just strong, they were over-engineered in the best way possible. Each piston had 5 rings with chrome-plated top rings, which is unusual for an engine that didn't even spin at crazy high RPMs. 3 of those rings handled the compression seal while the other 2 kept oil consumption in check. The chrome plating added extra durability and helped dissipate heat, meaning these pistons could last for thousands of hours even under harsh conditions. The pistons featured full floating wrist pins, a race engine design that allows slight rotation, spreading wear evenly and prolonging the life of both the piston and connecting rod. Ford engineered this engine for long-term durability, ideal for tanks in combat zones. 12. Full floating wrist pins, a race engine feature. The Ford GAA V8 engine utilizes full floating wrist pins, a design characteristic commonly found in high-performance racing engines. In this configuration, the wrist pin is not fixed to either the piston or the connecting rod. Instead, it floats within both components, secured by circlips. This setup reduces friction and wear, allowing for smoother movement and higher RPM capabilities. Additionally, it minimizes thermal expansion issues, as the wrist pin can expand independently of the piston and rod. This design choice enhances the engine's durability and performance, making it well-suited for the demanding conditions of military applications. 13. 8-way gear-driven accessory drive. The Ford GAA V8 engine features an innovative 8-way gear-driven accessory drive system, eliminating the need for belts or chains. This system drives essential components such as the fuel and water pumps, magnetos, and generators, ensuring reliable operation under combat conditions. By using gears and shafts, the design minimizes power loss and mechanical complexity, enhancing the engine's reliability and reducing maintenance needs. This gear-driven approach was a significant advancement over traditional belt-driven systems, aligning with the military's demand for robust and dependable machinery. 14. 60-degree V-bank angle. From V12 to V8. The Ford GAA V8 engine's 60-degree V-bank angle is a direct adaptation from its predecessor, the V12 engine. This design choice was not arbitrary, it was a strategic decision to maintain manufacturing efficiency and structural integrity. By retaining the 60-degree angle, engineers could leverage existing tooling and design elements from the V12, facilitating a smoother transition and reducing production costs. This approach exemplifies the ingenuity in adapting existing designs to meet new requirements, ensuring both performance and practicality. 15. 198-pound flywheel was needed to tame the beast's vibrations. The flat-plane crankshaft of the GAA had a lot of torque, but it also had a significant vibration issue because of heaving. Flat-plane cranks naturally shake more than cross-plane designs, and when you combine that with a massive V8, you get a recipe for rattling chaos. Ford's solution? A 198-pound flywheel. This monstrous disc smoothed out the engine's pulses, making power delivery manageable and reducing vibrations that would otherwise jolt the tank crew. The flywheel calmed the engine and maintained speed during load changes and gear shifts, which is vital for tank maneuvering. Together with a twin-disc, 17.5-inch clutch, it managed the engine's torque while enabling smooth shifts. 16 4-bolt main bearing caps were eventually deemed overkill. The early GAA engines rolled out with diagonal 4-bolt main bearing caps, a beefy, almost absurdly strong design that made the bottom end nearly indestructible. On paper, it was overbuilt for anything the Army could throw at it. But Ford engineers eventually realized that for tank use, this extreme reinforcement was unnecessary. Machining and assembling those 4-bolt mains slowed production and added cost, all without delivering any tangible advantage for the tank's slow, heavy-duty operation. Later GAA production models ditched the 4 bolts in favor of standard 2-bolt main caps, and yet the engine's legendary durability didn't skip a beat. This shift simplified manufacturing while proving just how rock-solid the basic GAA architecture really was. 17. Governor removal by tank crews unleashed hidden power. Out of the factory, the GAA came with a governor that capped engine speed at 2,600 RPM. But tank crews quickly discovered a trick. Remove the governor, and the engine's real potential was unleashed. In life-or-death situations facing heavier German tanks, or needing a burst of speed, crews would bypass or completely disable the governor. With the restriction gone, the V8 could rev all the way to 3,800 RPM before valve float became an issue, producing far more horsepower than the official rating suggested. This wasn't some risky, rare hack. It became almost standard practice. Maintenance crews often turned a blind eye, knowing that survival sometimes depended on extracting every bit of power. 18. Engine variants powered everything from Shermans to recovery vehicles. Most people know the standard GAA engine from the M4A3 Sherman, but Ford didn't stop there. They actually built several variants to handle different military needs. Take the GAA for instance. It powered the heavier M26 Pershing and came with modifications to survive higher stress and longer battles. Ford even dusted off the old V12 idea and turned it into the GAC engine, cranking out a shocking 770 horsepower for prototype heavy tanks like the T-29 and T-32. What's fascinating is how adaptable the GAA family was. It powered everything from tank destroyers to self-propelled artillery and even armored recovery vehicles. 19. 3,800 RPM redline capability far exceeded tank requirements. On paper, the GAA ran tanks at a safe 2,600 RPM, but it could actually spin way faster, up to around 3,800 RPM before the valves started to float. That's insane for such a massive engine and a direct carryover from its aircraft roots, where engines had to handle long stretches of high-speed operation without breaking a sweat. The secret was its direct-acting DOHC valve train and lightweight components. Unlike traditional pushrod engines, which struggle with flex and heavy moving parts at high revs, the GAA kept perfect valve control even when pushed hard. 20. Legendary reliability rarely required major combat service. One of the most remarkable things about the Ford GAA engine was just how bulletproof it was. Despite being used in harsh combat conditions, this engine could run for over 2,000 miles, or around 255 hours without needing major service, a remarkable figure for any power plant, especially one inside a tank. Its strength came from a combination of solid engineering, conservative tuning, and gear-driven accessories that kept everything running smoothly. Soldiers in the field quickly noticed this reliability. Unlike many other engines of the era which broke down frequently under stress, the GAA just kept going. 21 M4A3 Sherman tanks became the Allied armor backbone thanks to the GAA. The M4A3 Sherman became the workhorse of the U.S. Armored Forces late in World War II. This wasn't just any upgrade. The combination of the engine's raw torque and dependable performance gave Sherman crews an edge against German armor. Suddenly, the medium tank could keep up, maneuver, and sustain itself longer on the battlefield. After the war, the Army saw the value of this engine-tank pairing and standardized the GAA-powered M4A3. Many of these tanks were later upgraded with the HVSS suspension system and stayed in service well into the 1950s, a testament to their enduring design. The GAA wasn't just an engine, it became a symbol of American engineering reliability. And that's the story of the Ford GAA V8, a beast born for the skies but forged in the mud, powering Sherman tanks and shaping armored warfare history. From groundbreaking engineering to unstoppable torque, this engine proves that true innovation doesn't follow rules, it dominates them. If you love discovering these insane facts, smash that subscribe button and turn on notifications so you never miss a deep dive into legendary machines. Got a favorite fact? Or know another engine that blew your mind? Comment below and share your thoughts. We want to hear from you. Remember, history may be in the past, but legends like the GAA live on.